All right, had to go to the rollers, just had to, okay? This power supply is not in play, so those lights are out. We're getting track power, as you can see, the transformer is on. We're getting track power. We're going through a buckboard, which is, this is converting AC to DC. This is driving the DC down to some number, I think it's about 11 volts right now. So this is a hot line. This is getting its power through the PC using the USB port. This is the motor controller. It gets a go forward and backward signals here. And this is a trim pot that is giving a volt reading, or ohm reading inside here. And this guy is reading that. And when that number reaches 50%, it stops. It's in neutral. So let's see if I bring this back right there. You can see the motor is stopped. We're in neutral. If I keep turning, it'll start going in the opposite direction. And we can see that up here because now we're going forwards. We're going forwards. And now what I'm going to do is go back the other way. And here you can see we're now going in reverse. So you go through the neutral, and what we would do on our handheld, we'd have a white dot or something and then an arrow, so you line those up and you'd be in neutral. I don't know what that screaming is. I'll have to figure that out. But in any case, this is how we can control this. Now, if I had this all on a tether or something, I could run this, go over there and run this on the track. Okay? And we're not running. We're only giving it 11 volts. We're limiting everything to 11 volts. And I don't know amp draws. It just seems like it's a little sluggish. This is a pulse width modulation, and I don't really have a good handle on. I know it sends information in modulated and pulses, but I don't really know what that means to a brush motor. If it can handle it, or how it handles it, or is it lossy? I don't know. Okay, but what I can tell you right now is this new chassis, totally 3D printed, wheels, everything, is now running on an ESP32 with a trim pot going from forward to reverse through neutral, and a little screech. And I've limited it to 11 volts today. We'll go up to 17 is the expectation. So you'll see another, pretty good bit of power coming. But that's the track. That's the chassis I want with this controller. And this is the first day this thing has absolutely done what we thought it could do. And a lot of learning on my part. As you can see, this is a whole different test rig, a whole different setup. It's totally organized. It's color coded. Test lights showing us where the power is and isn't, and measured everything, tested everything multiple times, finally figured it out. The last piece was I didn't ground this board properly, and we were stuck. We're losing 2 volts. Couldn't figure out where it was. We grounded this, and that allows it to settle all of its circuits properly, and it pulled right up to 11.3 volts, which is what we were feeding. We're feeding in 11.39, and the motor is now getting 11.30. So you're losing 0.09 volts through the system, which is like nothing, I am so happy. This is going to be awesome. We are going to have a lot of fun. What happens now is we're opening now the controller, and the software is now reliable to the degree that we can now add and change things and know that the core function of forward and reverse is rock solid. And when we add something, we'll test it separately, then we'll put it in. That way we can stay out of trouble and make sure everything is doing what it's supposed to. Just a great day. I'm way over. I begged Margaret. She said, yes, I understand. Go for it. So we're good. We're getting out of here right now so I don't get killed. And I know she's got a chicken dinner. It's my favorite chicken, and I want some. So we're leaving. We're leaving right now. Great success. I hope you got enough of it that you could see it. All right, later.